Hello everyone, myself Professor Chilla, and we are going to study the subject called mechanics of structure. So for this, this is a syllabus introduction of the mechanics of structure. Okay, the subject code is 201002. The theory consists of 3 hours per week. The practical is of 4 hours per week in semester exam, and there are two types of exams: in sem and in sem. Okay, so in semester exam consists of 30 marks, which we are going to have in college in between the semester only. Okay, and end semester exam is of 70 marks. Actually, in semester exam consists of 3 units, and end semester exam consists of 6 units. Okay, the credit of this subject is 3. Okay, so next, moving onwards. Oh, so let's see what are the topics, what are the units to be covered in this mechanics of structure. Okay. The first unit is simple stress and strain. The second unit is shear force and bending moment diagram. Third unit is third unit is of shear and bending stresses. Fourth unit is torsion. Fourth unit is torsion of circular shafts and principal stresses and strains. Fifth unit is of axial stress and eccentrically loaded columns. Sixth unit is of slope and deflection of beams and trusses. Okay. So in this we are going to see next first unit. In the first unit we have to take the two we have two sections, like section A and section B. In the section A, there are some contents like material used in construction and their nature, means how the nature of the material is to be there, how the physical properties are, are there. We are going to see Hooke's law, stress strain diagram for elastic curve, elastic material. Okay. So next is plastic and brittle material. So elastic and plastic, these are two types of materials. Next is idealized stress strain curve, this stress strain diagram. Next, concept of axial stresses. So this we are going to see. Next, what compression and tension. Axial stresses are acted along the axis. Whether if the axis axis going through the cross section. Okay, so if the axis is of if the axis comes towards each other, so that is known as compression, and if the axis go away from each other, so that is known as tension. Okay, so strains. So what do you understand by strains, and what are the types of strains? Linear, lateral, shear, volumetric, these are the types of strains. Okay, change in dimension per unit original dimension is known as strain. Okay, so next is elastic constant and their relations. What is the elastic constants and how they relate to each other? We are going to see there are I think five or six relations to be studied in this subject. Okay, next, stresses and strain due to change in temperature. Okay. So next is stress, strain, and deformation in indeterminate structure. So there are two types of structures depending upon the analysis: determinate and indeterminate. What do you understand by determinate structure? Determinate structure are that structure which we can determine reaction or unknowns. We can determine by using simple equilibrium equations like summation of x is equal to 0, summation of y is equal to 0, and summation movement about any point is equal to 0. So by using these three equilibrium equations, if we can determine the sorry if we can determine the unknowns, so that is known as determinate structure, and if we can't, so that is known as indeterminate structure. Okay, next is homogeneous and composite structure under concentrated load and temperature changes. So what do you understand by homogeneous and composite? Homogeneous is made up of means it is a homogeneous material. Composite means it is made up of different materials. Okay, so under concentrated loads, And what do you understand? There are various types of loads. So first of all, in the mechanics, in the first year or in the previous diploma subjects, you have studied the concentrated load and temperature. Oh, sorry, the types of loads. That is concentrated load, UDL, uniformly distributed load, UVL, uniformly varying load, and so on. Okay, and the temperature changes. So this we are going to cover in the first unit. In the second unit, there is shear force and bending moment diagram. Actually, you know that. So what do you understand by shear force and what do you understand by bending moment diagram? So we draw this in the analysis of structure. Okay. So what do you understand by sharing? Sharing means it's an internal bond forces which the the what that is called, plates are going means plates are going to share in between each other. There are sharing. Okay, what do you understand by bending? Bending means it bends by some movement. Okay, so the concept of shear force and bending moment we are going to study. Detailed study of this is we are going to do. Next is relation between shear force and bending moment diagram. Next, intensity of loadings. So intensity of loadings means how the loading and bending moment diagram are related with each other. Next, shear force and bending moment diagram for determinant beams due to concentrated load, UDL, sorry, uniformly distributed load, uniformly varying load, loads and couples. So these cases are there. If the concentrated load is acting, how the shear force and bending moment diagram going to differ. If the UDL is acting, how the shear force and bending moment diagram differs. And if the UVL is acting, so this is so how the bending moment diagram going to differ. We are going to see in this unit. So next, bending moment diagram and loading diagram for given shear force diagram means from the given shear force diagram we can determine the bending moment diagram as well as shear force diagram. Okay, sorry, for loading diagram. So this we are going to see in the second unit. So next, moving onwards, unit 3, shear and bending stresses. Shear forces are different and stresses are different. So in the third unit we are going to study the stresses. Okay, so in the there are two sections, that is shear stress, and in the section A we are going to study the shear stresses in beams, and in the section B we are going to see going to study about the bending stresses in beams. So in the first section, concept of shear, complementary shears, derivation for shear stress formula, shear stress distribution for various cross section. There are various cross section we are going to use, circular, rectangular. These are the common cross section we are going to use. So what are the shear stress distribution along this cross circular or rectangular cross section? Okay, we are going to see in this unit. Next, maximum average shear stress for circular and rectangular section. As I already told you, the circular and rectangular cross section we are uh, commonly using this the two cross sections. So we are going to study about it detail. Okay. Next is bending stresses in beams. Say on in the section B. Okay. So say theory of simple or pure bending. What is simple and pure bending? We are going to say. Next is assumption. Next is assumption and derivation of flexure. What do you understand by flexure? Flexure is bending. Okay, flexure formula. Okay. So next, bending stress distribution diagram. Next is moment of resistance of cross section. Moment of resistance of cross section is an important factor or important concept for the civil engineer while designing. Okay, so next in the fourth unit we are going to study torsion of circular shafts and principal stresses and strains. So there are two sections as well. So in the first section we are going to study torsion of circular shaft. Okay. In that, theory of torsion, what is the theory of torsion? What are the assumptions are there? Derivation of torsion formulas, stresses, strains, and deformation, indeterminate and indeterminate shaft of hollow, solid, and homogeneous. Hollow, solid, and homogeneous. What do you understand by hollow? It is hollow in between. Okay, from inside. Solid shaft and homogeneous shaft. These are the types of shafts. Okay. Next is cross section subjected to twisting movement, power transmission by shaft. So this is the important concept while we are designing a crankshaft, like some shaft or some movement. Okay. So next is principal stresses and strains. In the section B, concept of principal planes and principal stresses, normal and shear stress on the oblique plane magnitude and orientation of principal stresses and maximum shear stress. In this unit, we are going to see that much. Okay. In the in the fifth unit, we are going to see axial and eccentrically loaded column. So axially and eccentrically loaded column. What do you understand by axially loaded column? Axially loaded column means the load, if there is a concentrated load on the column and it acts along the axis of that column, so that is known as axially loaded column. And if the load is acting some distance apart or some keeping some eccentricity, so that is known as eccentrically loaded column. So axially loaded columns, in the part A, we are going to see axial loaded column. So in that axial concept of critical load and buckling. So remember one thing: the beam fails by flexure and the column fails by buckling. Beam fails by flexure and the column, sorry, the beam fails by flexure, by bending, and the column fails by buckling. Okay, so this is the concept we are going to see in the unit 5. Next unit, Euler's formula for buckling load with hinged end, concept of equivalent length for various end conditions, Rankine's formula we are going to see, safe load on columns and limitations of Euler's formula. Okay. Next, in the section, in the part B, we are going to see the direct and bending stresses for the column only. For eccentrically loaded short column and other structures, component such as retaining wall, dam, chimney, and effect of lateral forces and self weight. You know that what do I understand by retaining wall? Retaining wall is that wall which retains some material. Okay, which retains some material or which holds some material. Okay. So next component adds. Okay. Next, moving onward, resultant stress diagram due to axially loaded column, uniaxially and biaxial bending. So these concept we are going to see in the unit 5. Next, concept of core of section for solid, hollow, and rectangular and circular section. Okay. So next, moving onwards. In a unit 6, we are going to see slope and deflection for beams and trusses. Actually, this part is also a part of structural analysis, which you will study in a coming year or in the next year. Okay. So, or in the next semester. So before that, this is there are some basic concepts like slope and deflection. What do you understand by slope, and what is deflection? So these are the two different concepts. Slope means there is some slope. If the bending is to be there, there is some slope. Okay, slope means there is some line going. If we draw a tangent to at any point, so it will create a slope. Okay, so that is known as slope. And what do I understand by bending? Bending means it is how by how much it will get bent, means by how much it will get bent. In short, we can measure the slope in terms of degrees, and we can measure the terms we can measure the deflection in terms of in terms of centimeter, like that only. Okay, so beams by Macaulay, this is one method, by Macaulay's method and stress strain method. Okay, so next is Castiglione's first theorem. Next is joint displacement method for determining determinate stresses by unit load method. So joint displacement method, we have studied method of joint for determinate stresses in mechanics or in previous semester of diplomas. Okay, so this is what the syllabus of the mechanics of structure. So if you have any query about it, any questions about it, or you have not understood what what I'm saying, so do not hesitate to talk. Do not hesitate to ask any question. So thank you. Have a nice day.